Correct.
out of
Over the
170.
total?
Yes.
Okay.
So maybe
And then it'd
maybe it's
be,
unclear how it reads. So it's so I to me I can see how it might be unclear that it's looking at, so just go with it. It's looking at the number out of the total, not the number out of the group itself.
okay, so then the 42 over 170?
Yes. So they're essentially asking you, how do you go from the smaller to the bigger?
Like, what's the difference?
Well, the difference would be 27 out of 170, which if you got a calculator, you'll find is not on this list, not on the A, B, C, D.
Okay.
So let's do this differently. Do you have a calculator handy?
Yes.
Okay. I want you to type in 69 over 170 and round to 2 decimal places, and then 42 out of 170 and round to 2 decimal places, and give me that number, please.
Okay, I got 0.41 and then 0.25.
Okay, so now what we want to figure out how to go from 0.25 to 0.41.
You go up.
Right. So the A and B are out. And it's essentially like asking like times what number? Times K. It's usually a K. It's like 0.25 times K equals 0.41. You don't want to do all this, but if you divide by 0.25 on both sides, and I'll go ahead and enter that into a calculator, 0.41 over 0.25.
0.41 over 0.25
Yes.
is 1.64.
So there's your answer. Okay, now I don't, that's why I was trying to get you to look at the original numbers. Okay, it's like, how do you go from the 42 to the 69 because the bottoms are the same? So let's try with a different example here. Let's just try with some numbers here. Let's say it's 25 out of 931, and we're going to 40 out of 931.
You go up 15.
Right. So like you go up, you add 15, but when it says times, you have to figure out the percentage that you're going up. So here are some options for this problem. 10% or 0.1, 25%, 50%, and we'll go 75%. Basically, I'm asking you how much bigger is 40 compared to 25, but not in terms of like addition.
It's just like percentages.
Yes, or it's really a decimal, but so this would be 0.1, 0.25. I'm sorry, 1.1, 1.25. I got all these. Sorry, 1.5, 1.75. So it's the ratio. It's like, what is 40 over 25?
Uh,
You're allowed to use a calculator, but like, it's like, can you get reasonably close without?
1.6.
Is it really 1.6?
Yeah.
Okay, sorry. So this will make the 60%. Shows bad numbers.
So I'm looking for that 160.
Yeah.
Okay, that makes more sense.
Let's try one more here. Let's say it's 58 out of 237, and you're going to 76 out of 237. I want to know how many times 76 is greater than 1.58. So I'm asking you for this, but I'm not like, I'm hoping you can try to estimate it.
Like 1.25, 1.3.
Okay, so take 58 in your calculator and multiply by 1.3.
75.4.
Yeah, so it's pretty close. Okay, I think you got it. I mean, these are just, we don't know. We don't know what exactly you will see, but these are just ideas to think about. I mean, it's really
Yeah,
about
no,
number.
it's probably good to practice this anyways.
Yeah. Let me do it differently. Okay, let me just try to give you an application here. Are you there? Sorry, are you there?
Yeah,
Okay. Do you mind sharing your current weight?
197.
Okay.
How dare you ask me that?
I have to ask. I have to ask. All right. Let's say you wanted to go to 205 pounds. Okay.
Okay,
And the problem is really asking you, how many times bigger do you need to get?
probably like 1.05.
Okay, but before you answer that question, like let's just say you wanted to get 0.5 times bigger, which is a little weird, but like, what would that mean? What would your weight actually drop to, roughly?
Drop to or
Yeah,
gain?
drop to, because it's 0.5.
Oh, probably like 190.
No, 0.5, half.
Oh, it'd be one. No, not even one. It'd
You'd
be,
you'd be about 100 pounds, roughly.
yeah, like
Okay,
93.5 pounds.
so it's weird, but one times
Like
bigger,
97.5.
one times bigger does not mean double. Okay, one times is yourself. Now, this is a math property, but the identity property of multiplication says that if you take a number and you multiply by one times, you get back that.
Correct.
Okay, so if you want to be 0.5 times bigger, which is weird, it's correct, you would actually go down in weight. So what I'm trying to get you to see is the one times gets you back to where you started.
So that one is just okay.
So when I was looking at this problem, I was trying to get you to say, and you did in this last problem, but it's like 1 times 58, 1 times 58 gets you to 58.
Correct.
And then you got to figure out, like, what fraction of the 58 do you need to get back to 77?
About 0.3.
0.3. So the 0.3 of 58 is around 618. Okay, roughly. And that's what I'm trying to get you to see here. So to answer our original question here, if you want to get bigger, it's like you said, it's 1 point and then a little bit to get bigger, because the one gets you back to yourself. Times one gets you back to yourself.
Yeah, that makes sense. Or more sense, I guess. Yeah.
All right, let's look at another question here. Different table altogether. So as a reminder here, there's a lot of words on the right, and I don't want you to read them unless you think you need to, but start up here. Go ahead and read this one out loud for us, and we'll see if you can do it by yourself.
If a ninth grade student at the high school is chosen at random, which of the following is the closest to the probability that the student will have a GPA of 3.0 or greater?
So we want to find GPA of 3.0 or greater. Where's that in this table down here?
The top one.
Now notice this one did not give you the total.
The
So
top left.
it's both of these though, because they could be enrolled in Propel, whatever that is, the water company. I don't know if it's
Oh,
Propel,
okay.
whatever. Like they could be, but it's both of them.
Okay.
But they're not giving you the total. Sometimes they do, sometimes they don't. So when you add these together, 156. And what is the total of everything without
Ooh.
adding? Say that again.
Without adding, like
Yeah, without
171?
adding. Like is it somewhere else?
Oh, 327?
Yes. Okay, now with estimation, tell me which answer it is in the table, roughly.
About probably 0.4, wait. Yeah, 0.48.
Yeah, it looks like it's a little bit less than, 0.5. Good. All right, I'm just grabbing another question for us to look at. All right, so let's not read this. We'll start here at the bottom here. What proportion of adults who received a sugar pill reported contracting a cold? So here's the sugar pill. We only care about sugar pill.
Okay.
So how many of those people contracted a cold?
Contracting means like having
Yes.
33,
33 out of what?
150.
Is that answer here A, B, C, D?
No.
So this is one of the first ones we've seen where it actually is reduced. I don't really understand why they don't reduce some, but don't reduce the others. But you have to be able to reduce this. Now, assume you do not have a calculator for the moment. Can you find a number that goes into 33 and 150?
3.
Yes. So you divide both by 3. What is the
11 over
numerator? What
50.
is the denominator?
11 over 50. So B.
Yes. Okay. Now let me give you this problem again, but with a different, asking you for a different question here. Okay, so what proportion of adults who I guess none of these answers are, all right, never mind. We'll move on to another question. All right, so here's a problem to try on your own. It's very helpful you're telling you the word not, so just pay close attention to that, please. But go ahead and see what you come up with for that answer.
The table above summarizes the results of 200 law school graduates who took the bar exam. If one of the surveyed graduates who passed the bar exam is chosen at random for an interview, what is the probability that the person chosen did not take the review course? So it's asking, out of the 200 students,
Yes, the 200 is like the total of everyone.
did not, so 200 and then I do 80. That did pass the bar exam. So it'd be 7.
7 out of what? Because it's either B or
Two,
D.
7 out of 200.
Okay, so let's look at it one more time. If they had to have passed the bar exam, how many people passed the bar exam?
Oh wow. 25, is that?
25. Yeah. Now, like it's not a general rule to find all the totals. But in this one, it would have been good to recognize that one. So it's 7 out of 25. So let's try a related question here. I'm going to just change a couple of words. Don't look, if you can, maybe look away from the screen for a moment. Okay, so here we go. It's the same question, except it's saying if one of the surveyed graduates did not pass, did not pass the bar exam, what's the probability that they took the review course?
Did 93?
So they did not pass but they took the review
Oh, okay.
course.
82. Sorry.
82 out of what this time? It's none of these answers, but that's okay.
What is that? 175? 185?
Yes,
175?
175. All right, so let me see if I can grab another one. So we need to talk a little bit about this conditional probability stuff. Let me grab a previous question. So we'll just talk a little bit about conditional probability. Okay, so the most basic probability questions they could ask you would be something like this: the probability of vitamin C. Can you tell me what that would be in this problem? Probability of vitamin C. So how many vitamin C's out of the total?
Oh, 150?
Okay, so in words, this is a row. We're looking at rows. And I could ask you the probability of a sugar pill. What would that be?
150?
Out of 300, so it's the different 150. I could also ask you the probability of a cold.
53?
Sorry, what did you say?
54?
54 out of 300. And the probability of no cold?
246?
246 out of 300. Okay. And notice these are columns. Is that clear or not?
Yeah.
Okay.
Yes, yes.
So those are the basic ones. Okay. Now I'm going to we're going to look at this problem again. But we're going to just talk a little bit about, basketball or any, I like talking about basketball. We talk about golf, whatever. But my question to you is, do you score more points on average at home or on the road?
On the road.
Really? So why do you think that is? Is that, but your bench plays a better role at home? Maybe, players pass to you more often on the road. What do you think is the reason of that?
Yeah, I think it'd be the players pass to me more often because they're scared to mess up in front of the crowd.
Okay. Yeah, that very well could be. So, if I asked you the probability of scoring, given that you are away, and the probability of scoring, given that you're at home, these might be different, right?
Correct.
Okay, now in terms of like how we would calculate the away, you have games, you have different games away versus home, obviously. And I don't know who you're playing, but you have different games. Would you, is that
Yeah. Yes.
so but if we want to know the probability of you scoring, do you agree that it would be both of these?
Yes, because it'd be combined.
Yes. So the conditional probabilities are looking at just away or just home. What
They're
they are doing
specified.
is, say that again. Yeah, they're reducing what's called your sample. So you have a smaller sample when you're conditional. Okay,
Okay.
and that's what this previous problem about law school was trying to get you to do. It was trying to saying like I don't care about the total. I care about those who pass the bar exam. So out of the people that pass the bar exam, that's what I care about. Then I gave you another question about those that did not pass the bar exam. And it's just like we just talked about with scoring. It's like, okay, how do you do on away? How do you do at home? So we're going to look at that in the context of this same problem here one more time here. See if we can get this down. So, and it would be written this way. If you have a cold, so what am I reducing this data set to now? This table to?
Having a cold.
Just this one. What is the probability that you take a sugar pill. Which number in the column do you care about?
33.
You only care about the 33 now because your world is the 54. And the one you care about is the 33. So there's language that like restricts this, and it can be done in a column or in a table, or a row. So it could say something like if you take vitamin C, right? So what is that restricting us to?
Just vitamin C.
Just this row. Just this row. We don't care about anything else going on, just this row. What is the probability of no cold
129.
out of?
150.
Yes. So the conditional probability always reduces like what you're looking at. Is that okay? Is that clear?
Yeah, that makes sense.
All right. So what do you think about this? Do you think that's true? Do you think if you take vitamin C, you're more likely to not have a cold?
Yes.
Yeah, it really is amazing. I mean, it's all right. Let's try one more of these. I think this is a conditional one. No, this is a difference one. Okay, let's switch topics. Let's go to I don't think we've done this yet. Maybe we have. Yeah, we have. Okay. Have we done inequalities yet?
Inequalities?
Yes.
I think a little bit. I'm fine with whatever.
Yeah, I'm just trying to find one that we haven't done yet. All right, so we'll do some word problems here. All right, I'm not gonna put the multiple choice in yet. We're gonna work on converting words to equations. Okay, so that if we go down to the question here, it says, which of the following systems of inequalities represents the conditions described if X is the number of junior directors and Y is the number of senior directors? Okay, so now let's go back. We're gonna look at this sentence by sentence and see how to convert. So Marissa needs to hire at least 10 staff members for an upcoming project. Okay, so it tells you now, if you keep reading here, the staff will be made up of junior directors and senior directors. But that's already down here, junior directors and senior directors. Now, in terms of an equation, there's a question for you here. What does the word at least mean in terms of an equation or a symbol? And here are your options. This one, this one, this one. Which of those is at least?
I think the bottom one.
This one means at most.
Oh.
And the
'Cause
red left
second
to
to
right.
bottom.
Yeah, at least. Sometimes it's better to put these in terms of like something you know, okay? And it's like I need to score at least 25 points in the game. So if you score 25 points, is 25 at least 25?
Yes, that's
Yes.
the bare minimum of 25.
Yes. Now symbolically, I don't know how to help you. You just have to figure out how to do that, how to like remember that.
Okay.
I don't have a good way. Sorry. So this is saying X plus Y needs to be greater than or equal to what number?
10.
10. Okay, now let's look at the answers. Sometimes it's good to look at the answers right away. This is one where it would be overwhelming to look at them. So I want you to find the answers that have this in there. Which one has that in it?
A and C.
A and C. So B is out. I'm sorry. You're looking at the wrong ones. Sorry here. It's not responding. Come on. Oh, man. Okay, here it is. This one right here.
B,
So A
B and
is a
C.
B and C.
B and C.
Okay. Okay, so just with one sentence, you've gotten it down to 2. Okay. Now notice we're just focusing on the inequality. Like you actually don't even need to get the right equations. You really need the inequality direction, because now look at B and C. What is different about them?
The sign.
The sign. So I want you to read the rest of this and determine which sign it is. And I'm just going to step away for 30 seconds or less.
Her budget for paying the staff members is no more than 9,700 per week. She must hire at least 3 junior directors. At least one senior director.
All right, I'm back.
So it would be at most to the 9,700.
No more than, right? No more
Yeah.
than. Yeah. So which of these symbols would it be?
At most.
Yes. So which answer is it?
The B.
Yes. Let's look at another one. So before we look at the question, we're going to look at the answer space now. And I want you to focus on the signs of the inequalities. So I'm trying to train you to do here is to look at the answers and see what's the same, see what's different. So look at the first equation in all of these. What's the same, what's different?
They are all at most.
Yeah, another one, the little wrinkle here, they're kind of reversed. Like this, to me, this indeed, the second equation really should be the first. Okay, so that's not going to help you. So what else is different is the numbers. Do you see how the right-hand side here is different?
Oh yeah.
It's another thing to look for. So let's see if we can go back and well, and actually snip in the questions. Let's actually look at the question now and see if we can figure out what we're doing in this one. All right, so let me snip that in, come back to that. All right, a worker uses a forklift to move boxes that weigh either 40 pounds or 65 pounds each. Let X be the number of 40-pound boxes and Y be the number of 65-pound boxes. The forklift can carry up to 45 boxes or a weight of 2,400 pounds. So my question to you now, and you may have to reread this again, is does the 40 and the 65 go with the 45 or the 2,400? And if you need to, please read it again. Don't just guess
The
at it.
2,400 because they're pounds.
Exactly. The pounds go with pounds. So the equation with 40 and 65 better go with 2,400. Okay, so let's look at the answers one more time. And you tell me which ones we can eliminate.
C.
C's out.
Um,
So I
would
can tell
B.
B is out because of this right here, this division. And the reason is if you carry a 40-pound box and then you carry another 40-pound box, how many pounds of boxes have you carried?
80.
80. So multiplication is like adding. That's why B is out. Now look at A and D. What's the difference between these two equations?
D is saying 2 boxes has to at least be 2,400
Yes.
versus 40 X boxes and 65 Y boxes can be at most 2,400.
Yeah. So the like what they're giving you here is a pounds equation and then like a total equation. And that's pretty common. Like one will tell you using the unit of whatever's given. The other one will be like these two things added together can be more than or less than a certain number. Do you want to go back and read the question, or do you think you can tell me which is the correct answer?
I think it's I think it's A, but I could be
It
wrong.
it is A. Have some confidence. Don't be like your players that are afraid on the bench, afraid to score in front of the crowd. Do you know there's people that they like when they get booed? It gets them.
I kind of like it, to be honest.
Yeah. If you can find someone else in your team that's got that mindset, you could really like, if they are really not bothered by it, they will eventually rise up to the challenge. But that's where your coach has to know that too. He's got to know like who's okay with that. All right, you ready to do a problem on your own?
Yeah.
All right. All right, so take as much time as you need here, but I'm going to ask you why you chose the answer you chose. So be prepared to answer that. Take as much time as you need to figure this one out.
A carpenter with 60. Oh, wait. Hold on. If N represents the number of boxes of nails and S represents the number of boxes of screws, which of the following systems in inequality models this situation? A carpenter has $60 with which to buy supplies. The carpenter needs to buy both nails and screws. Nails cost $13 per box. Screws cost $15 per box. Nails and S is screws. At least one.
Do you have any questions for me?
Uh, no. Is
And you,
it D?
okay, so I'm gonna ask you a few questions. The carpenter has $60 with which to buy supplies. Can you tell me what that means in some other context?
Like he could buy as many. Like, can I keep the same story or does it
Change
have
the
to?
story. Change the story. Like it's Black Friday. What is
Okay,
Black Friday?
let's say I need to go get new pencils, and it's
Pencils.
and the
You're not buying pencils. Come on.
okay,
Go buy something fun.
okay, okay. I got $6,000 to spend,
Okay.
and I need a new TV and a car.
Okay. Better.
So the car can be as much money as it is while being able to afford a TV with it.
Okay.
So
Can you spend
the
more than the $6,000?
no,
Why not?
because that's the budget.
That's all you have. So it doesn't say it explicitly. It doesn't say at least, at most. It just says this is what you have. And it's implied that your understanding of real life is that
is at most.
at most. It's the same thing with like time. When you play a game, play sports, time usually it runs out. You know, there's
Correct.
exceptions like in the World Cup where they add time. There's overtime, of course, but like you have to know that that is it. So based on that, obviously answer A is out. Okay. Good. Okay. Now, why did you pick letter D? What is it about D that is different than I'm sorry, and letter C is out. I apologize. What is it that about D that's correct over B?
Because it says that he needs a box of screws and a box of nails. He needs to get both. And in D on the two bottoms, it says N and S at least one.
Okay. So now use your well, maybe that's not great, but can you think of something where you only need one? You would choose one or the other, but not both.
Wait, what?
Okay, so let's use your example. Let's say you could buy car A or car B. Okay, and N is car A and S is car B. Would you ever buy two cars in your current situation?
No, let
No.
alone one.
Okay, but you could buy neither, right? Maybe they're too expensive or you don't have, you don't like them. So N plus S less than or equal to one. What this means is you would generally only buy one or the other. Does that make sense in letter B, why that's that way?
Yeah,
Okay,
yeah.
whereas D is like, hey, I might need two boxes or I might need 5 boxes of the other ones and so
While
on.
still having one of each
Yeah,
at least.
and that's now there are situations that it's like I either ride my bike to school or I take a car, but you wouldn't do both for whatever reason. Okay, one more and then we'll maybe switch topics here.
Was D the answer?
Yeah. Oh yeah, let me circle that. Sorry. Yes. Sorry. Yeah. We haven't done much with inequalities. That's where we're spending a little more time trying to like understand the language in them. This one has some at most at least in there. So go ahead and take a look at this and try to work it out with that approach, please.
Which of the following systems of inequalities represents the situation in terms of the number of hours he will work at his lawn service job? L, and the number of hours he will work at his job at the gym G next week. Jonathan needs to earn at least $175 next week and can work at most 20 hours. He earns $10 per hour at his lawn service job and 8 hours or $8 per hour at his job at the gym. So, which of the following system? Sorry, I'm reading this way too
That's
many
okay.
times.
That's okay. No, this is good. It's good to read it and reread it.
Represents the situation in terms of number of hours he will work at the lawn service. So A and B are out
Why are they out?
because it says at most instead of at least, and he needs to earn at least 170.
Okay, good.
O plus G. Would it be C?
Why is it C?
Because it says at most 20 hours.
Yes. Okay, now you made a comment like, oh, sorry, I'm reading this so many times. I want to ask you something about something you do in basketball, I'm sure. Someone passes you the ball, okay? And you want to shoot, right? Do you ever do anything besides shoot? So you're going to shoot the ball, but do you ever do anything before you shoot the ball when you're past the ball?
Yeah. I
What
like,
what is
I
something you
look
might
at
do?
the, I look at the floor and make sure like I have a good shot to get
Okay.
up or if there's a better shot to take.
Okay. So so here's what I'm asking you is, do you ever dribble the ball one time before you shoot? I'm sure you've seen this on TV if you haven't seen it before. Yeah.
Sometimes, yes.
Okay. So sometimes you make an adjustment, we'll call it. Can you give me a reason why you might make an adjustment before you shoot? And you just gave me one. Make sure you're behind the 3-point line. Why is that important?
Because I don't want to shoot a long 2-pointer.
Exactly. Because the percentages say you might as well go 6 inches back because even your probability of make is essentially the same. What's another reason you might make an adjustment?
Defense.
Get the guy to move. That's why you might take a dribble. Guy's running at you, you take one dribble, move left or right. Okay. Any other reasons you can think of?
I'd say off balance.
Yeah, I was going to say sort of the same thing. Like you don't like the way the ball fits in your hand. You're not quite set up correctly. And I'm sure the list goes on and on, right? What is your ultimate goal when you're shooting the basketball?
To
To
take the
make it,
quality shot. Yeah.
to make the basket. We've talked about a couple of ways to decide whether you're going to do a problem. And one of them is I know how to do it. I just need a tiny bit more time. And that's what you're doing here. And when you're adjusting, you're like, all right, I'm going to make this shot, but I just need a little thing here. Same thing with this question. Do not apologize for taking more time. Say, I'm doing it because I want to get this question right. That's my ultimate goal. All right, let's look at another question here. So I want you to look at these graphs and tell me what is different about each graph.
The shaded area.
Very good. So if two lines intersect, and it doesn't matter where they intersect, there are 1, 2, 3, 4 regions.
Correct.
Okay. Now we've done a problem like the following here. Let me pull it up here. Sorry, just didn't get this quite snipped in. Here we go. So we've done a problem like this before. And do you remember how you solved a problem like this?
Yeah.
We substituted in. And the reason is because these two lines, one of these points, like this might be A, this might be B, this might be C, and this might be D. That's why we did it, because there's only one region that's correct.
Okay.
So when you're testing these points, only one of them, now it could be that there's multiple ones in the wrong region, but let's just say for the purpose of this, that there's one in each. Okay. So when they give you a graph, and I'm not sure you will, but they might give you a graph, you do not graph the inequalities. You pick a point in each region. Let me snip the question in. You pick a point in each region to test. Okay, so let's look at A. What's a point in region A that you like? Well, you can see that. It's only to zoom in more.
I'd go with 0, 0.
I love it. Yeah, 0, 0. So I want you to test 0, 0, and it has to work in both.
No.
Does not work in the first one. So that's out. Okay, now in the next one here, actually, let's go over to D because D is a little bit better here. It's better to choose something along one of the axes, like 4, 0. The reason
Okay.
is the reason is 0 gets rid of one of the variables.
Okay.
Okay, but again, so go ahead and try this in there and see if you notice anything, if it works, doesn't work, and so on.
It does not work.
Which one does it not work in?
The first one?
Yeah,
Because
and you only
4
have
is
to,
X?
yeah, and you can choose which one you want to try. So that's out. So in C here, I like that point there along the axis.
Okay.
And
So 0, 4?
okay, so that's actually a little further up, but that still
Oh,
works.
0,
Still
3,
works.
sorry.
Doesn't matter. Yeah, you pick. So see if that works, and it has to work in both.
Yes. And 3. No.
So what's the answer?
B.
Do we need to check it?
No.
No. All right,
Unless the ACT is wrong.
they're not wrong. Let me stop recording for a second.